I see Dr. K came in and said hi as a speaker. What's up, Dr. K? If he's here.
Props to a listener. Let me add him.
Okay. No, he's here. He might be busy working on course though, so he might just feel along.
Hey guys, how's it going?
Guys,
oh, there we go. Sweet.
Got a big group today. Almost 60 people.
Yeah. Good turnout so far. I'm just scrolling through the list, seeing if I see any familiar faces.
Yeah, I think it's bigger too. We've heard from some of the Russian community that they don't get counted in this list for some reason. So
Twitter censorship. We're trying to fight against.
Dr. K, you want to go into, we were talking about lightning earlier before you were on, and I know you've brought up a few times the problem with lightning, and I'd love to hear that, and I think the group would as well.
Yeah, so I mean, there's a couple different issues that exist with lightning. One of them is really that Bitcoin can only do 5 TPS. So if we say in the long term, Bitcoin's inflationary block rewards go to 0, the security in the network, the payments to the miners, has to be fully provided by transaction fees. And if you just kind of assume where Bitcoin is in terms of its current price, just kind of assume where Bitcoin is in terms of its current price, or if Bitcoin were actually be globally used as money, it would obviously have a market cap much higher than that. The transaction fees themselves at 5 TPS to maintain network security are going to be very onerous. On the low end, maybe it's $50. On the high end, maybe it's $1,000 a transaction. So that's you as just not being able to really security long term as a layer 1, but that ties into what you can do with a layer 2. So if Lightning were, say, used ubiquitously to open or close a channel, maybe you have to spend $1,000, and how often do you want to spend $1,000 to open or close a channel into Lightning? Now, the problem with Lightning itself is it requires liquidity providers or hubs to do sort of multi-party channels. So a state channel itself is really just between two parties. But to make Lightning useful, you need to connect to a hub that's connected to many people, and then you can actually use Lightning with many people. And those hubs useful, you need to connect to a hub that's connected to many people, and then you can actually use Lightning with many people. And those hubs have to provide liquidity for the net amount that's locked in the channels for the users of the channels. So initially, those hubs are doing that for free, out of altruism, out of support for the network. But in the long term, obviously, if somebody's locking up cap, they would expect a return on their money. So not only are those nodes centralizing, but those nodes will eventually be rent seeking. So if you look at what Lightning's really proposing, it's proposing something that looks a lot more like a Visa MasterCard type system, where you're always paying fees on your money to an intermediary to facilitate transactions. You can do a Lightning-esque network, but if your layer 1 is so deficient that you can't reasonably settle on or off, it's going to really strengthen the centralization and monopolization of those liquidity providers and the fees that they can charge. So those are the two main issues with Lightning. So those are the two main issues with Lightning.
Mic drop. Anyone? Oh, Raleigh, you got dropped. I'll bring you back up to the stage. Does anyone have any questions or follow-ups?
Thanks for that. Yeah, I know we were just talking about it earlier, and I know you have the best explanation of the problem. So I'm glad we got the audience to hear that.
Yeah, it's interesting when you talk to Bitcoiners. They always will tell you Lightning's the way to scale, but they can never answer some of these questions. The response I got from somebody was, "Well, why would I want to have return of money or like ROI on my capital?" Right? Which is pretty hilarious. But yeah, it seems to be a fallacy. The other thing that's interesting about it to me is I always felt Lightning was sort of a better proposal than some of sort of the Ethereum-based L2 situations. Optimism. But sometime this year, I kind of looked at it some more and realized how identical Lightning is to the ethereal sort of L2 situations. You still have watchtowers, you still have entry and exit periods that are order of potentially certainly days, if not weeks. You technically have a fraud issue and fraud proving that takes place. So it's vastly more certainly days, if not weeks. You technically have a fraud issue and fraud proving that takes place. So it's vastly more similar and as complicated as every other sort of L2 solution that's proposed. For whatever reason, I didn't mentally categorize it in the same group, but it's very identical to something like Optimism.
Carl, I know we had a conversation yesterday kind of about money and currency. Can you kind of give like a quick rundown of how Quai differentiates itself from something like an Ether or Bitcoin as money and currency and something that can be used rather than just speculated on?
Yeah, that really just boils down to throughput, right? It's actually interesting. If you kind of look at unique, say, transactions on Ethereum, for example, and this was even during peak times, late last year, let's say, you were seeing maybe 400,000 unique active daily users. And if I told you there was technology that had 400,000 daily actives and it was worth, and if I told you there was technology that had 400,000 daily actives and it was worth $600 billion, you would appropriate response to that would be that system is vastly overvalued. And right, so Ethereum sort of gets a lot of its value and use like strictly through speculation and some of this financialization stuff, but clearly looking at the number of daily actives relative to the market cap is an indication that any system that only operates at 5-10 TPS is vastly overvalued, and unless they can increase that transactions per second by 3 orders of magnitude, so 1,000x, they're going to remain vastly overvalued. So they can never actually fulfill the purpose as money. So I think one of the other things that was interesting that I pointed out yesterday when we were talking was every time a project markets some specific use case, it's really an admission that the project and the underlying blockchain technology that they're using cannot fulfill the sort of value-added use case of crypto, which is money. So, for example, when Bitcoin says that Bitcoin is digital gold, that's not a good thing. That's a bad thing. Now, they're marketing that as a good thing, but wouldn't it be cool if you could have a crypto that could be simultaneously digital gold and digital money and, digital oil and digital silver? But each one of these cryptos, because they can't actually fulfill the ubiquitous role case as digital value transfers, they always try to look for specific use cases and brand into that as being a good thing and not an admission of failure. So other examples, right? Ethereum at one point said they were, the world computer. Then you look at like IPFS. IPFS has a token just for file storage. And we've kind of like accepted these sort of segmentation of domains as something natural in the crypto world. But imagine how ridiculous the world would be if I had to have an Amazon token to go get AWS cloud services, or I had to have an Uber token to get a car ride, or I had to have a gas token to go fill up my car. I mean, all of these like segmentations of tokens to specific use cases, just admitting that the current technology in crypto cannot fulfill its promise of being ubiquitous, trustless value transfers. And then everyone that brands into it and creates new blockchains and fragmentations, they're just taking advantage of the fact that the technology hasn't come to fruition to fulfill its promise. And in the long term, all of those use cases are going to collapse and go away.
I think that's a really interesting point. And I think that like really resonated as the fact that just, you don't want to use your own token to go to the gas station. You don't want to use a different token to go to AWS and a different token to go to the grocery store. So it's a very like digestible, easy way to like view the crypto world as it is today and the vision that we have for what Kauai will be in the future and what it's trying to be is that ubiquitous source of like value transfer across all platforms, across all use cases, rather than just a specific vertical.
Yeah, I mean, think about think about if we did live in that world and then somebody came up with a token and you said, oh man, this token's great. You can use this token at the gas station. You can use it for your AWS.
The vision that we have for what Kauai will be in the future and what it's trying to be is that ubiquitous source of like value transfer across all platforms, across all use cases, rather than just a specific vertical.
Yeah, I mean, think about think about if we did live in that world and then somebody came up with a token and you said, oh man, this token's great. You can use this token at the gas station. You can use it for your AWS. You can use it for your Uber and all the other things. Would you rather live in a multi-chain world and have the cognitive overhead of running multiple wallets against multiple ecosystems over multiple bridges so that you could just go about your daily life? Or you'd be like, maybe I should just have this one token because I don't have that resistance and cognitive overhead and technical overhead of managing many things.
Yeah, it's like every major store, gas station, travel business has a credit card. So imagine if you had to use that credit card for that place or business only. Is essentially what we have in the crypto space or people building currently.
Yeah, and it's like ridiculous. It's just somehow the crypto space has branded it in a good way to make it appealing, but if you dig past the branding, it's actually just revealing the very nascent nature of the industry and the fact that no one's really solved the actual problem.
We're about to.
Oh yeah, I think that's kind of the
actual problem.
We're about to.
Oh yeah, I think that's kind of the segue there is that we're providing the infrastructure of something that can actually support that.
Yeah, I mean that's
cool
exactly right. That's the whole point. Yep.
Yeah.
Of Quai. So actually fulfilling the promise of crypto. But it's interesting, right? Like people have gotten sort of inculcated by that marketing over the last decade. So people are like, Bitcoin's great, it's digital gold. And then they never have really internalized what that means.
Here to shake things up a little bit. The reversion back to what crypto was supposed to be originally, the original ethos.
Yeah, well, I mean, how cool would it be if you could be digital gold and you could be cash and you could be rewards points and you could be stocks and you could be derivatives and you could be everything else? If you have one system that can do everything that has to do with ethereal representations of value, wouldn't you want to own that token versus one that can like barely service a highly specified niche with a single purpose token?
Absolutely. That's just like a no-brainer decision there.
Yeah, I mean, it really crushes the sort of conversation of like the multi-chain world. Like the multi-chain world is just a transitory period before we figure out how to have a single network. But it's gonna go away.
Yeah, absolutely. Does anybody have any questions? I think we're kind of getting close, or relatively close to wrap-up time.
Yeah,
So we got Kazim just got brought to the stage.
Yeah, do you have a question?
Guys, can I ask a question?
Of course.
Absolutely.
This is my first time. I'm a researcher at VVV, and it's my first time actually hearing about Quai. So I was reading about on your website. It says you guys are modular, which would imply some sort of like either some layer, specifically the execution layer, settlement layer, data availability layer. So I'm just curious, how is your? I was reading about on your website. It says you guys are modular, which would imply some sort of like either some layer, specifically the execution layer, settlement layer, data availability layer. So I'm just curious, how is your blockchain a modular blockchain?
So there might be lack of specificity in some of those terms. We separate things not by execution, data, computation, etc. But effectively, what we've done is we've separated consistency and consensus um, through having different chains that effectively have different scopes over different period of time. So, right in our hierarchy, if you're saying a zone blockchain, you can get 10-second sort of settlement. Now, sort of certainty of finalization, ultimately has to do with work put upon that block after, or the transaction after it's been processed. But if that transaction is only in that zone, we would consider that to be locally scoped to that context. If you want to go cross context, depending how far you want to go, right, that could take anywhere from 5 minutes to 2 hours. So we separate out sort of the scope of data. So it's certainly sharded in that regard. But you pay for throughput by having variable times of finalization depending on scope.
Yeah, thanks.
We also have a lot of articles on our architecture that include visualizers. If you'd like to check those out as well, I definitely would recommend looking into our Medium if you haven't already, just to help visualize that.
Yeah, I mean, I was just reading a little bit about it. Well, you guys are EVM compatible, but does that mean developers can easily? I mean, why would somebody that was building on Ethereum want to come over? What's the selling point, the use case, other than say maybe it's faster, or maybe it has? But I mean, other than the technology itself, is there something that you're geared towards that you want to attract developers to say develop protocols that they feel like is more suited for your blockchain as opposed to Ethereum?
Yeah, I mean, it's protocols that actually have like legitimate economic use cases, not just strictly financialization of artificial products. Because effectively, what we can do through the sort of hierarchy of merge mine chains is we can incentivize miners and nodes to self-select, but self-select in an optimized way their footprint in the network, which optimizes network times and minimizes the number of hops for propagation. And in doing that, with the hierarchy, which can horizontally expand with demand, the goal is, right, we can do, a transaction for, say, a penny, and we can kind of guarantee that that will be a penny today, it'll be a penny tomorrow, it'll be a penny from 10 years from now. So we can guarantee throughput at fixed cost over time and scale. So if you actually want to make like a business, you can have a safe assumption about the costs of using the blockchain in that business case.
Yeah, it makes sense. Yeah, it's a good selling point.
Yeah, I mean, ultimately, at some point, maybe it's 100,000 TPS or like 200,000 TPS. Nothing's absolutely free in the world. So as the blockchain keeps scaling, the time to global settlement will linearly increase. So maybe at 100,000 TPS, it'll take you 10 hours to globally settle from, say, one zone to a distant zone blockchain, and to go to 200,000 TPS, then it will take 20 hours, right? So we can keep going through scale. Yeah, I mean, ultimately, at some point, maybe it's 100,000 TPS or like 200,000 TPS. Nothing's absolutely free in the world. So, so as the blockchain keeps scaling, the time to global settlement will linearly increase. So maybe at 100,000 TPS, it'll take you 10 hours to globally settle from, say, one zone to a distant zone blockchain. And to go to 200,000 TPS, then it will take 20 hours, right? So we can keep going through scale, but right, nothing in a physical system is free. So that's sort of the compromise.
And I don't want to keep going. I know you guys are trying to wrap this up, but does a blockchain solve for MEV? I mean, is it render that zero, or is it something that you guys address? Is it render that zero, or is it something that you guys address?
That's something that we're currently working on. So we have a system of blinded pre-commitments that we're using. It should largely solve for MEV.
Thanks. Appreciate you answering my questions.
Yep. No, they're good questions. We appreciate you coming and asking them. And if you have more, feel free. I mean, good questions are good questions. I'll stick around. So.
Yeah, I'm just curious because somebody comes up with an L1 blockchain. I mean, these days it's just like there's so many of them. So you wonder, the technology is all different, right? And if a developer has to come and learn a new language, and port through a bridge, and so everybody needs to try there. And I'm sure you've been a user before, you know that trying to get over to some other blockchain that's not yet, broadly used, so it's difficult to get over to. It might have to get through a centralized exchange, but it gets really complicated, and also you risk having to move your funds through a bridge, and new users don't even know what a bridge is. So those are all like the sort of like, yeah, the blocks of a new L1. You got to find a way to get over there. So I'm sure you guys have addressed these things. But
Yeah,
definitely...
I mean, you can definitely help facilitate that with centralized exchange listings. You can facilitate that with bridging, and if you look at bridging across EVM platforms, it's like a slight difficulty, but the friction isn't certainly as high as going across non-EVM platforms. If you look at bridging across EVM platforms, it's like a slight difficulty, but the friction isn't certainly as high as going across non-EVM platforms. Because normally you can use a single tool like MetaMask to do it. And that's something we're looking to address. But I mean, the longer term sort of thesis is that people don't want that friction and don't want those things, and don't want that friction and don't want those things, and you need a decentralized, scalable system to prevent having to do that all the time, and that's really what we're going for. Right. So once they come over to Quai, they'll never leave. They'll never leave. They'll never need to leave because we can just provide the service.
Interesting. Yeah, I appreciate it. Yeah, it's a lot of questions, but I'll have to take a closer look at the protocol and the network, and just get more informed. So
yeah, I mean to kind of key you into what the main piece is. It's that it's a hierarchy of merge mined blockchains. So we're effectively able to asynchronously have the blockchains reference each other, which creates a hash linked reference, which causes the simple use of work, which we call proof of work 2.0, as a mechanism to facilitate interchain interactions. So you don't, our network, I wouldn't call it a bridge, because what ends up happening is you get mined in. So the process of mining, the process of block creation, eventually ties all of the blockchains back together, and that's how you get hash linked references. So there's no sort of security assumptions. There's no sort of extra overhead in moving between any of the chains in the network.
Yeah, I'm thinking of one other chain that does this, and I was just looking for it. They have they can scale, and they can scale, and they have several chains, and I'm almost like in parallel.
Are you thinking about Kadena?
Yes, exactly. Yeah.
Yeah. So Kadena's interesting. but if you dig into the problem more deeply, you can understand that they're fundamentally flawed. So effectively, Kadena runs parallel chains, but they make it a requirement that the miners must reference three other chains when producing a block, which gets them referencing. But there's a randomization process for creating those backlinks. And basically what that does is it forces everybody in the network to simultaneously run all the nodes. So they've sort of parallelized execution, but the real bottleneck in blockchains isn't the execution at the moment, it's the data propagation and the latency of the data propagation. So why we're different is that a miner can exclusively run what we call a slice. So they have to run three of the chains. It's a hierarchy, so they have to run prime, and they can pick a region and pick a zone. So they have to run three of the chains, but that's all. But that's all they ever have to run. And what that does is it segments the data stores and the data propagation points. So and not only does it segment it, but if they're mining, they're incentivized to segment it in a network efficient way. So that is how the miners are then incentivized to find one of the subset chains which has peering, which minimizes their latency and minimizes their hops. And in doing that, so if for example, if you look at Bitcoin, if we think about the nodes as like a regular n by n graph, the average number of hops to traverse the network is going to be n log n, right? Order n log n. So if we take a subset and we divide n by, say, in our initial case, 9, you have n over 9 log n over 9. And if we put that in terms of numbers, right, Bitcoin may take like 7 hops, and their ping latency may average, say, 100 milliseconds. So it'll take 700 milliseconds to go across the network. But if you look at the optimization of subnetworks, and which would happen through these incentives, right, you might get that down to 3 hops in 10 milliseconds. So you're looking at a 30 millisecond propagation problem versus a 700 millisecond propagation problem. So within that subset, you're vastly more performant. So even as an Ethereum only chain, if you're propagating transactions in even just a naive gossip format, you can go from, say, 10 to 500 TPS just on that network performance increase.
Yeah, it's complicated.
Yeah, no. I mean, it's really complicated, but the throughput of these systems are actually measured in milliseconds.
Yeah.
Right, and you can look at the differences in milliseconds. So it's milliseconds of
It's fast.
how fast data can propagate. It's milliseconds regarding input-output seconds, regarding input-output operations on disk. It's milliseconds in processing state. And all of those things are milliseconds, and all of those things you can trade one for the other. But the biggest bottleneck we have in the system is the network milliseconds. And then if you go outside the network milliseconds, you would start to get into drive access milliseconds. But if I can reduce my network milliseconds by 20x, right, I can increase my TPS by 20x as long as my state size doesn't change. Right, but then if I want my state size to go up or down, right, I could decrease my TPS.
Mm-hmm.
But everything in the system is all milliseconds, and like there's a fundamental bandwidth related with that millisecond, and whichever one of those things is sort of the pinch point in the system, and you can trade every one for every other.
Okay.
So that's how we're addressing it, right? So like we think of the whole system in milliseconds.
Okay. Yeah. I'll leave with this because I work at a VC anyway. We do Twitter Spaces like this, and we do get a lot of listeners. Sometimes up to 6,000-7,000 over a course of a few days. And so keep in touch. It'd be cool to maybe have you guys come and talk about what you're doing.
Yeah, no, absolutely. We'd appreciate that. If you want to drop a DM into the Quai chat, we can keep it going.
Yeah, I'll add on to that. Please shoot me a DM and maybe we can figure out a way to co-host something. I think that'd be
Yeah,
awesome.
yeah. Because we've just recently we had Fuel and John Adler, if you know that is, but he's the optimistic roll up guy. Anyway, yeah, a bunch of really cool people. Eigenlayer guys are doing a lot of modular blockchain stuff. But yeah, I'll drop some information in there, and maybe we can keep in touch and get you guys on there.
Yeah,
Yeah,
awesome.
please do.
Appreciate it.
We
Okay,
definitely stay in touch. You've asked some great questions. I've enjoyed listening.
great, cool. I appreciate it. Definitely.
Well, thanks, guys. On that note, if anyone else has any questions, feel free. But I think we are a little over time. I think we need to get back to some work and actually build this blockchain. So I really appreciate everyone for tuning in. Thank you, Dr. K. Thank you to the rest of the team. And thank you to our community. So unless anyone has any last second things, I'm going to close this up.
Yeah, thanks everyone
Thanks,
for
y'all.
coming. We'll see you guys next week.
Yeah, see ya.
Thanks.
Thanks, everyone.